This is not about tourism. It is a collision between static opulence and kinetic energy. To mount a 5-star villa onto a truck chassis is a brutal engineering challenge. Luxury is heavy. A single slab of marble countertop weighs as much as 2 passengers. Multiply that by an entire interior, and the vehicle fights the laws of physics at every turn. How do you force a building to travel at 100 kilometers per hour without tearing the suspension apart? 30 years ago, builders used plywood and glue. Today, they use military-grade composites to cheat gravity, mass versus motion. The analysis begins in the assembly halls of Colorado. The first solution to the problem of weight and drag is variable geometry. On the highway, the Kimberly Caravan acts as a 5.5-meter projectile. In transport mode, its roofline sits barely higher than a standard family crossover. This is not an aesthetic choice, it is fluid dynamics. The low profile allows the unit to hide within the slipstream of the towing vehicle, drastically reducing the coefficient of drag. Arrival changes the physics. The high-pitched whine of a hydraulic pump cuts through the desert silence. Pistons drive upward, the roof separates from the chassis, the internal volume doubles. Inside, the engineering philosophy shifts from aerodynamics to durability. The skeleton reveals a critical decision: the absolute rejection of timber. Most RVs use wood. Wood rots. Wood warps in humidity. Under the vibration of washboard roads, wooden frames disintegrate. Kimberly uses aviation-grade alloys and high-density composites. The structure is immune to mold. While the interior offers diesel heating and induction cooking, the real luxury is the absence of structural decay. This system relies on agility and smart materials to survive. But to conquer the most vertical terrain, we need to leave the lightweight class behind and switch to brute force. While the Kimberly relies on aerodynamics to slice through the wind, this monster simply ignores the elements through brute force. The EarthRoamer SX abandons the concept of agility for industrial rigidity. It is built on a Chevrolet 6500 commercial chassis. This is a platform designed for heavy haulage, not highway cruising. The scale of the components is difficult to grasp without a reference. The vehicle sits on military-grade tires measuring 43 inches in diameter. The top of the rubber stands as high as the chest of an average adult. This gigantism is not aesthetic, it is a structural necessity. Beneath the composite shell, the chassis must manage massive shifting loads. The onboard reservoirs hold 1,000 liters of fresh water. That is 1 metric ton of liquid mass moving inside the frame. To handle this, independent air suspension at each corner isolates the cabin from the ground. Sensors detect body roll and inject high-pressure air into the springs instantly. The truck remains flat while crushing rock. This engineering dominance comes with a price tag of $1,500,000. From the brute force of the United States, we shift to German management of critical mass. The Morello Empire liner attempts a structural paradox, integrating static architecture into a dynamic projectile. Inside the bathroom, the walls are lined with real natural stone, heavy, brittle, unforgiving. In standard construction, road vibration shatters granite plates within 50 miles. The engineering solution lies behind the surface. A cross-section of the wall reveals the secret. The stone veneer does not touch the frame directly. It floats on a specialized adhesive bed. Flexible polymers absorb kinetic energy. The rigid wall dances with the chassis instead of fighting it. The stone remains cold to the touch while the engine beneath generates furious heat. This mineral cladding alone adds weight equivalent to a Fiat 500 to the vehicle's payload. Survival here requires autonomy. The water system uses high-intensity ultraviolet radiation to sterilize the flow. Microorganisms are eradicated at the molecular level before they reach the tap. Outside, a 360-degree camera array scans the perimeter. Infrared sensors detect thermal signatures in total darkness, spotting intruders or wildlife long before the human eye adjusts. But the most expensive material here is invisible. The cabin is wrapped in 42 millimeters of RTM hard foam insulation. The world outside screams at 60 miles per hour. Inside, there is only absolute silence. But the main enemy of heavy liners is not weight, it is crosswind. This 13-meter Integra Coach cornerstone acts like a massive sail against the elements. A sudden gust usually demands brute force from the driver to keep the lane. Here, physics is managed by software. The Easy Steer system reads the lateral pressure. An electric motor applies precise torque to the steering column in milliseconds to counter the push. The driver feels nothing. The road stays straight. Inside the shell, the timeline breaks. While the chassis executes digital commands, the cabin reverts to 18th century manual labor. The furniture is crafted by the Amish community of Indiana. No hollow plastics or composite molds. You run your hand along the cabinetry and feel the dense, irregular grain of solid hardwood. It is heavy. It is real. This mix of archaic craft and robotics relies on the Aqua-Hot 450D. The boiler burns diesel to generate unlimited hot water and hydronic heat. It keeps the stone and wood warm regardless of the blizzard outside. We have successfully isolated the passenger in a mobile fortress. But now we face a logistic dead end. Where do we put his second car? While some increase wall insulation, Vario Perfect cuts movable mechanical airlocks into the body. This is the 1200 Platinum, a 26-ton German fortress sitting on 3 axles, with a price tag of 1.6 million euros. Most manufacturers avoid the rear overhang. It is a leverage nightmare. Vario ignores the risk. They engineered a hydraulic garage specifically for a Mercedes SL or a Porsche 911 right at the tail. The rear gate lifts. A low-frequency hum indicates the hydraulic pump is priming. Steel ramps extend to the tarmac. Loading a car here creates a dangerous pendulum effect. You are placing 1.5 tons of dead weight behind the rear wheels. The laws of physics dictate that the front axle loses traction while the rear takes a massive hit. The pressure on this rear bogie now exceeds the axle load of a standard commercial freight truck. Inside, lithium banks provide 72 hours of autonomous silence for the circadian lighting. But the real tension is outside. The platform lifts the vehicle. The clearance is a matter of millimeters. If the air suspension sags by ½ an inch, the carbon fiber bumper scrapes the highway. The clamps engage the tires. The hydraulic hatch seals shut with a metallic thud. Vario loads the tail, creating a dangerous pendulum effect. Volkner solves this by shifting mass to the geometric center of the chassis. This 18-ton unit carries the curb weight of a light tank. It ignores the rear bumper entirely. Instead, a patented hydraulic slider extends laterally from the wheelbase. It is a steel tray engineered to lift a Bugatti Chiron. The contrast is mechanical. Delicate automotive carbon fiber sits millimeters above industrial hydraulic rams. By locking the vehicle between the axles, the center of gravity remains low, eliminating the sway that plagues rear-loading models. The garage consumes the chassis' useful volume, pushing the kitchen island and technical systems into tighter confines, but the luxury remains dense. The onboard Burmester audio system alone costs 300,000 euros, the price of a standard city apartment. If Volkner hides the car in the belly, then Anderson Mobile breaks geometry upwards, ignoring aerodynamics. While most RVs expand horizontally, this machine challenges gravity. The operator engages the sequence, and a high-pressure hydraulic circuit floods with oil. The entire chassis shudders. Fluid rushes through steel-braided lines, forcing 8 synchronized pistons to extend simultaneously. The roof creates a deep mechanical groan as it detaches and rises. In exactly 30 seconds, the trailer creates a second floor out of thin air. This is not a canvas pop-top. The upper deck houses a fully equipped cinema capable of seating 30 people. The structural stress on the lifting mechanism is immense. If one piston lags by a millimeter, the frame twists and the glass shatters. To support this 30-ton skyscraper on the move, the vehicle requires 22 wheels. That is 4 more than a standard heavy-haul freighter. Without this aggressive axle distribution, the static load would drive the tires into the asphalt like anchors. The price for this hydraulic defiance is 2,400,000 euros. While known as Will Smith's on-set fortress, the celebrity status is irrelevant compared to the engineering footprint. This is a mobile 3-bedroom apartment. When the hydraulics lock into place, the total living space expands to a staggering 110 square meters. Anderson is brute hydraulic force. The Newell Coach P50 is comfort micromanagement via a digital data bus. While the exterior spans 14 meters, the true engineering density is concentrated in the cockpit. This is a collaboration with Porsche Design, built not for a chauffeur, but for an owner who drives. Your fingertips meet the cool, tactile resistance of the control surfaces. No plastic rattles here. Behind the leather trim, miles of fiber optics replace standard copper wiring. The software complexity rivals a modern airliner. A single tap on the interface adjusts the opacity of the glass or fine-tunes the heated marble floors. Beneath the chassis beats a massive heart, the Cummins X15 engine delivering 605 horsepower. Why does a luxury bus need the torque of a quarry hauler? To ensure that a 20-ton vehicle accelerates like a sedan. With a range of 2,000 kilometers, it devours continents without effort. Inside, the roar of the diesel beast is reduced to nothing. Newell optimizes internals, Marchi Mobile tries to cheat air resistance with the outer shell. The Element Palazzo Superior is a collision of engineering and aggressive bio-design. Its form echoes the 1970s, where Luigi Colani prioritized organic curves over industrial corners. The front fascia is dominated by a single piece of glass, the Insect Eye windshield. It offers 180 degrees of visibility, but its primary function is aerodynamic flow. The air does not hit a wall, it slides over the curvature. Beneath the glossy white skin lies the critical component, carbon fiber. Layers of woven graphite replace heavy steel. This material choice drops the vehicle weight significantly. The physics are undeniable, a 20% reduction in fuel consumption compared to standard boxy hulls. On a trip of 1,000 kilometers, the efficiency gap becomes a chasm. However, the engineering often takes a back seat to the visual impact. In the Gulf states, this silhouette serves as a status marker for oil magnates, valued for its shock factor rather than its drag coefficient. All previous palaces become useless the moment the asphalt ends. The Unicat is engineered for a world where roads no longer exist. While other manufacturers polish marble, Unicat reinforces the chassis of a Mercedes Zetros 6x6. This is a complete rejection of aesthetic luxury in favor of pure survival functionality. The machine is designed for a scenario where civilization has collapsed. The engineering focus is absolute mobility. The driver activates the central inflation system while moving at speed. Compressed air hisses through the hub lines. The massive tires flatten out, increasing their surface area by 40% in seconds. The truck floats over shifting sand where a standard vehicle would sink to its axles. Inside, the atmosphere is clinical. The scent of polished wood is replaced by the smell of sterile, fire-retardant textiles and cold aluminum. Every piece of furniture is bolted directly to the frame to withstand extreme vibration. Two tanks hold 800 liters of diesel, enough energy to power a small field hospital or cross a desert without refueling. The system guarantees 30 days of total autonomy. Standard luxury creates a bubble. Unicat creates a fortress. When the route is blocked by a river, the six-wheel drive engages. The truck plunges into water 1.2 meters deep, wading up to the driver's waist, and pushes through the current to the other side. Unicat dominates the wild, but the Prevost H345 Liberty coach conquers the grid. Here, the engineering challenge shifts from mud to mass. Standard buses bolt a body onto a frame, but Prevost builds a monocoque structure entirely from stainless steel. It is a rigid, integrated cage, zero flex. This structural integrity is critical because the interior load is crushing. The chassis must carry tons of solid Italian marble flooring and heavy Murano glass ceilings without compromising stability. Inside, the sensation is pressurized stillness. While the highway roars at 70 miles per hour, the cabin remains dead silent. Safety protocols are stripped directly from commercial aviation. Avionics monitor every stress point in real time. However, the defining feature of this 3.4 million euro vessel is energy independence. A single power source is a liability. Engineers install a dual generator system in the bay. Two 20-kilowatt units run in parallel. Total output is 40 kilowatts. That is enough electricity to power 5 average family homes simultaneously. It creates a mobile command center that effectively cannot be powered down. While the Prevost optimizes the technology of today, engineers are already simulating the theoretical limits of the year 2026. The Kenworth T 2026 Custom Double-Decker is a glimpse into that future. It spans 18 meters of length. It rises 2 full stories from the tarmac. Placed beside a standard commercial hauler, it looks less like a vehicle and more like a rolling fortress. Moving this sheer vertical mass presents a critical engineering paradox. Standard diesel torque is insufficient for the projected weight. The solution is a high-output hydrogen-electric hybrid powertrain. This system is not designed for speed, but for the relentless, consistent torque required to haul a hydraulic glass elevator, a hydroponic agricultural unit, and a heavy-duty garage containing a 2,000 horsepower electric hypercar. The energy density of the hydrogen cells solves the equation of weight versus range. It grants the vessel total operational independence from the grid for a maximum of 30 days. Strip away the 18-meter hull and the heavy hybrid drive systems. True engineering density is not measured in tonnage, but in functional grams. The A-Liner Expedition represents a radical shift in philosophy. It is a kinetic puzzle box. 2 rigid fiberglass walls rise and lock together with a sharp metallic clack. The entire A-frame structure creates a weather-tight shelter from a flat profile in exactly 30 seconds. Total weight sits under 900 kilograms. That is lighter than a compact city car. This tactical lightness allows it to navigate fractured terrain where the previous giants would snap their axles. Inside, the layout is a brutal lesson in subtraction. Micro-architecture integrates a full galley and cassette shower into a 5-meter footprint. No wasted space. Release the tension latches, fold the walls flush, and the camp disappears before the dust settles. From the aesthetic efficiency of a folding tactical trailer, we cross the line into absolute engineering excess. The Featherlight Vantair Platinum Plus does not seek to save weight, it weaponizes it. This is no longer vehicle manufacturing, it is geology and architecture forced onto 18 wheels. The chassis bears a load that defies standard automotive logic. Rare Italian marble slabs line the entry steps, heavy, unforgiving. The walls are clad in African sapele pommelé. This is not a veneer, it is dense, rare timber with a quilted grain that absorbs sound and adds massive static load. Touch the hardware and the sensation is distinct. The cold, heavy conductivity of 24-karat gold. Above, the lighting system relies on the refraction of thousands of Swarovski crystals embedded in the ceiling. But the ultimate structural challenge lies in the underbelly. A hydraulic tray extends from the side of the chassis, hovering inches above the asphalt. A low-slung sports car drives onto the metal platform. The suspension settles. Hydraulics engage with a mechanical hiss, lifting the car and swallowing it whole into the bus's frame. To achieve this, engineers had to hollow out the chassis without compromising rigidity. The cost exceeds $2,500,000, equivalent to 3 substantial suburban mansions. At this level of density and expense, the machine ceases to be a mode of transport and becomes mobile real estate, which forces the engineering question: why integrate a garage inside a bus? The answer marks the end of rationality. We have analyzed the full spectrum of mobile engineering, from ascetic tactical trailers designed for survival to 18-meter palaces built for pure ego. It is a timeline of human ambition. To visualize the absolute peak of this industry, where production numbers dropped to single digits, we utilized high-fidelity artificial intelligence simulations. Watch the process. Raw technical blueprints dissolve into digital reality. Two-dimensional lines become three-dimensional chrome and glass. These are not artistic impressions. They are strict mathematical recreations based on verified engineering schematics. This technology bridges the gap between abstract calculation and tangible experience. If resources were unlimited and physics was your only constraint, which of these mechanical titans would you choose to command?